Hello to all. I am Dr. Alkesh Agrawal, and in this lecture, we'll mainly discuss about registers, the classification of register, and we'll finally discuss the design process of 4-bit universal shift register with parallel load. Here are some reference books that include Digital Design by M. Morris Merrow and M. D. Saletti, and Modern Digital Electronics by authored by R. P. Jain. So first of all, we'll in brief discuss what is a register. So in the previous lecture we have studied about different kinds of flip-flops. So register is nothing but it's a group of flip-flops that are capable of storing fixed amount of information, and that amount of information depends upon the number of flip-flops that are being connected, each flip-flop being capable of storing a single bit information. So registers, you can have an analogous comparison with the same register that you use to write information through your handwriting. So each register has number of pages and each page contains certain amount of information. Similarly, the registers, these are the storage devices that store some amount of information, and that amount of information depends upon the number of flip-flops that are being connected to have a register. If you see this diagram, so we have a classification of register as the first is serial in, serial out, abbreviated as SISO. Then we have serial in, parallel out, abbreviated as SIPO. Then we have parallel in, serial out, abbreviated as PISO, and parallel in, parallel out, abbreviated as PIPO. So these are the four types of registers that depends upon the way the information is being input and the way the information is read out. So depending upon how the information is written into and read out, we have four kinds of registers. One is called serial in, serial out, serial in, parallel out, parallel in, serial out, and parallel in, parallel out. So in, serial out, the information is serially written into the flip flop and serially read out. In serial in, serial out, the information is written serially in and read out parallelly. In parallel in, serial out, the information is depicted or written into the flip flops or registers parallelly and read out serially. And in parallel in, parallel out, the information is written into parallelly and read out parallelly too. So here you can see the diagram, which seems somewhat complex, but it's not very complex. So it is a universal shift register that mainly comprises of the number, the both the combinational logic as well as sequential logic. So here you can see it's a 4-bit register. Parallel to that, we have four multiplexers, which are 4 cross 1 multiplexer. This is the first multiplexer, second multiplexer, third multiplexer, and fourth multiplexer. And the output of each multiplexer is connected to the input of a D flip flop. So we have the first D flip flop, the second D flip flop, the third D flip flop, and the fourth D flip flop. Then we have a clear input. The clear input is mainly to clear the contents of the flip flop, which is active low input connected to all the clear inputs of D flip flop. Then we have clock. With every clock pulse, the transition of the flip flop changes. So this clock and clear is to control the D flip flop. Then to control multiplexer, we have selection inputs S0 and S1. We have two selection inputs because we have 4 cross 1 mux. Now you can see how these connections are being done. If you see this flip flop and this multiplexer in yellow color, so you can see this output. So the output of every flip flop is connected to the 0 of the same multiplexer to which it is connected. It is connected to 1 of the previous multiplexer, and it is connected to the 2 to the next multiplexer. So this is the connection for all. If you see this A1 is connected to the 0 input of the same multiplexer, to the 1 input of the previous multiplexer, and to the 2 input of the next multiplexer. If you see this A0 is connected to the 0 of the same multiplexer. There is no multiplexer before it, so no connection, and to the 2 input of the next multiplexer. If you see A3 is connected to the 0 input of the same multiplexer, input 1 to the previous multiplexer, and since there is no multiplexer uh, next to it, so no connection. So these are the connections. Other than this, at every 3 input of third channel of the multiplexer, we have parallel connections as I3, I2, I1, I0. Other than this, at input 1 of the first multiplexer, we have serial input for shift right, and at the second channel or second input of the fourth multiplexer, we have serial input for shift left. So these are the connections through which we have designed a universal shift register. So again, you can see for the every output of a particular flip-flop is connected to the 0 input of the same multiplexer, 1 input of the previous multiplexer, and the 2 input of the next multiplexer. So these are the kind of connections that are being repeated for every output of a particular D flip-flop. So these diagrams are being made in MS Visio originally. So these diagrams are not copied from anywhere. So these are originally made by me. So this is the functional table of a universal shift register. So we'll see how this universal shift register works for every selection inputs. So the first is, if the selection inputs are 0 0, there is no change in the contents of the register. That is, whatever is being stored will retained as such. If the selection inputs are 0 1, the data shifts to right. If the selection inputs are 1 0, data shifts to left, and if the selection inputs are 1 1, there is a parallel loading of the data. So let us see the first operation as 0 0. So you can we have animation effects in these slides, so we'll discuss one by one. So first, what we have seen is the content of the first. This is a register, 4-bit register as a whole. So in a 4-bit register, the first flip-flop has the value as 1 stored. Now we have given 0 0 as selection input. Now you can see this 0, the 0 value is being connected. The same value is coming to the 0 input of the same multiplexer. And when we give 0 0, we know with for a multiplexer, when in selection input is 0 0, whatever is input to 0 channel is selected out at the output channel. So this 1 is selected out through this multiplexer. If we assume the 0 is stored in second flip-flop, so this second 0 value is again coming onto the 0 channel of the multiplexer, and with the selection input 0 0, it is again selected out at the output of this multiplexer. If you assume again the third flip-flop has 0 value, so that 0 value is again uh, it will be shorted and connected to the 0 channel. So we have 0, same value 0 connected over here. With 0 0 selection input, the same value will be out of the multiplexer. And if we assume that the 4D flip-flop has one value stored in it, so that one value will, through this short circuit, will come to this 0 input. With 0 0 selection, it will be selected out. So you can see whatever value that is being stored in the register as 1001, the same value is being selected and out of a multiplexer 1001. Now when the clock is being activated, the same value will be retained with the register. So you can see the same value is being retained as 1001. So what we have seen over here is when selection input is 0 0, there is no change in the contents of the register. So this is the first operation. Now we'll see second operation as with input 0 1, the contents will be shifted right. Shifted right means from left to right. So what we have seen is this 1. We have seen that this 1001 is stored in this. So this 1, now this 1 is also coming to the one input of previous multiplexer. So we have shown over here. This 0 which is stored in second flip-flop is again through this short connection is coming to the first channel of the previous flip-flop. So this 1 which is stored over here is through this connection is coming at this input, and the 0 which is stored over here is coming through this connection at this input, and again this 0 which is stored over here is coming at this input at one channel. Now we have given 0 1 as selection. So what will happen? And we are giving 0 input to this one. So at this one channel, first input we have an external input 0. At this one, this is the value which is stored in first flip flop. At this input of one input of this multiplexer, we have the value which is stored in second flip flop. And at this input, at input of this multiplexer, we have the value which is stored in third flip flop. Okay. So now when we have given the selection input 0 0, so this whatever coming at the one channel, channel 1 of all the multiplexer will be selected. So you can see this 0 is selected and out of this multiplexers. So the contents change from 1 to 0. From here, the one input that is coming at this channel 1 is selected out, and the contents change from 0 to 1. With again 0 1 input, this 0 is selected and out of this multiplexer, the contents are 0 to 0, and this 0 input is selected through this multiplexer, comes out of the multiplexer, and the contents change from 1 to 0. So what you can see, the previous contents were 1 0 0 1. So in this flip flop a new data is being stored which is given externally at 0. This 1 data is stored in this flip flop, this 0 is stored in this flip flop, and this 0 is stored in this flip flop. So you can see the contents are shifted to right by 1 bit. So this is called shift right operation. If we see the third operation which is shift left, so we assume that 0 1 1 0 1 0 1 is stored in the flip flop. We have assumed this, and now since again what we are now seeing from right to left, so whatever stored in this flip flop through this connection is coming onto the channel 2 of the next flip flop. Then the 0 that is stored over here is coming onto the second channel of the next flip flop. The one input that is stored in third flip flop is coming onto through this connection at the second input of this next flip flop. Again we are giving a 0 input to this second input of multiplexer 1. Now we are giving selection input 1 0. So now you see this 0 which is coming onto the second input channel through this selection input 1 0 is selected out of this channel, and this value is changed from 1 to 0 when this clock is being activated. This one value which is coming on to the second channel of the second flip flop, when with selection input 1 0 will be selected of this multiplexer, and the data will be stored and will change from 0 to 1. This 0 value which is coming on to the second channel of this flip flop will be selected out, and the contents will change of this flip flop from 1 to 0, and the data which is coming onto the second input will be selected out, and the contents will change from 0 to 1. So you can see the new data has entered into this flip flop, and this 0 is shifted to this flip flop, this 0 is shifted to this flip flop, and this 1 is shifted to this flip flop. So the contents are being shifted left from this flip flop to this flip flop, this flip flop to this flip flop, and this flip flop to this flip flop. And in the right flip flop we have a new data over here. So this is called shift left operation in universal shift register. If we see the last operation which is parallel load, so we assume the contents are all clear to 0. Now we have given a value 1 1 1 1 at I3 I2 I1 and I0. Now we have given 1 1 to the selection input, and we know that when 1 1 selection input is given, whatever comes at the third channel will be selected through this multiplexer. So these 1 1 values are selected through this multiplexer out on this output channel, and these value when the clock is activated will be stored in this flip flop parallelly. So contents are changed from 0 to 1, from 0 to 1, 0 to 1, and 0 to 1. So you can see the data is being fed parallelly, and it is uh, stored parallelly into this all the stages of a shift register in first, second, third, and fourth flip flop. So contents from 0 0 0 to change to 1 1 1 and 1. So this is how universal shift register works in 4 mode. With no change, with no change, left shift, right shift, and parallel load. Thank you.